Hey, this is Brock Lemire's. We are continuing looking at embedded systems design. In this video, we're going to look at a useful design tool called a flowchart. And I tucked this into the program flow instructions section, a chapter actually, because when you really start thinking about programs selectively executing different segments of your code or your program, based upon decisions that are being made, you start really having a hard time kind of wrap your brain around what's going on in your program, especially when you're typing at an instruction by instruction level. So the design can become very complex if you just sit down and stare at the screen and are just trying to type assembly and trying to keep track of what's going on in your head. So a flowchart is a design technique where you create a graphical depiction of the behavior of a program, and it allows you to develop the algorithm of your program prior to implementation. And this is actually how you're supposed to do software design. You're supposed to think through the algorithm first, not just open up a file and just start slamming stuff down and compiling and see if it works. So let's go through the components of a flowchart. So you're going to have these little shapes, and they're each going to represent different things. And this is the basics of a flowchart. So we're going to look at the 1, 2, 3, 4, 5 elements of a flowchart. The first shape is an oval, and this represents the start or the end to a program. So it's just a quick way to kind of say, it's like, oh, here's where we're beginning the program. And most embedded computer programs, they don't end. But anyway, so then a rectangle is a process instruction or a sequence of instructions. So I look at a rectangle as kind of like a specific thing that is being done. Okay, and it can be one instruction, but it can also be a group of instructions. Okay, so I think of it like if you were going to add two numbers, you could have that be one rectangle. But as part of that add, you might have had to go get the inputs from memory or from a port and bring them into internal registers. So it may have taken a couple different instructions. But this rectangle becomes very powerful because it represents an instruction or a set of instructions that are kind of doing some specific thing. And these become really critical when you start looking at conditional jumps because you can kind of think of these as little blocks of code that may or may not be executed based upon some test instruction. And yeah, okay. Then a diamond represents a decision. So this is where the true power comes in. So you're going to basically have some sort of question stated here, and then you'll have the points that come out of it represent where you could potentially go. And then finally is the rectangle with double sides. We will have as we develop more complicated programs, we're going to start developing things like subroutines or service routines that may actually, we can run them in our main program, but they might actually be considered something that kind of runs behind the scenes. And so to keep that functionality in a flowchart, we put these double sides on it. And a lot of times these can kind of sit over on the side outside of the rectangle or the regular flowchart. And then there's the directional flow. So this is just where you're going to go next. Okay, so the easiest way to kind of look at or to learn about flowcharts is let's look at some very basic flowcharts for the common programming constructs that you'll see in something like C. So here's the code for a while loop. So you're going to say while var1 is equal to 3, stay in this loop, and each time through this loop, assign var2 a 1. So what we would do here is you would have a decision, and the first thing that happens is you have to make a decision as to whether to stay in the loop. And so you're going to state the question is var1 equal to 3. Is var1 equal to 3? And if it is, you're going to stay in the loop, and that is represented by this kind of closed path right here. But when you do it, you have a little process that you need to do. So you have a task. So I always put yes or no by the arrows because the question is going to be answered by, typically it's a Boolean question, especially for a while loop. And you'll have a little process here that says var2 is equal to 1, and then you will return up here and you will stay in this loop. And if not, if var1 is not equal to 3, you'll go this way. And you notice that you're writing this out at a very descriptive text level. You're not putting instructions in here. You're not doing a move instruction. You design this first, then you can break this up and say, okay, now I'm going to implement the structure for the while loop, jumping, and then here is where I'm just going to put a sequence of instructions that'll accomplish that. Okay, another one, for loop. So let's think about this for loop. You're going to have a loop variable I. It's going to start at 0. You're going to, each time through the loop, it's going to increment by 1, and you'll stay in the loop as long as I is less than 4. And then each time through the loop, you'll assign var1 the value of the loop variable. So this is what a for loop might look like. First and foremost, you initialize the loop variable to 0. Then you go into the loop, and there's a decision. And so you check to see whether I is less than 4, and if it is, you go ahead and make the assignment, the statement of var1 gets I, and then you also have to increment the loop variable. And so you can see there's two processes in this closed loop. And then you come back into the decision and you have to check, is I equal to less than 4? If it is, you do the loop again. And then is I is less than 4? And I is less than 4. And you will step through this looping, this kind of closed loop structure right here as many times as it takes to get I not less than 4, and then you pop out. Okay. Another very common one is an if-else statement. So consider this. This is our if-else code in C. If count1 is 10, do this statement. Otherwise, do this statement. Okay. So this one's kind of simple. You're going to check the question you're looking at is count1 equal to 1 or is equal to 10? If it is, go this way. If it's not, go this way. And then you can put the different functionality in these little process blocks. And then you either do this one or this one, and then you exit. Now this becomes very powerful because when you design this, then you can really think through how you're going to set up your conditional branching and whether you're going to use tests or compares right here. In this situation, you're trying to see if count1 is equal to 10. You probably are going to use a compare for that, and it was really obvious because you see this. And then you can look at how you need code for both of these paths, but only one of them is executed. So that helps you keep in mind how you're going to jump. You're going to have this over here, execute that, but you got to jump over that. So that's a very simple else if statement. Then the switch statement. So the switch statement, you can kind of, it's really like a very large if else statement. Consider this switch statement here. So you're going to look at an input var in, and you're going to say, if that is 0, var in is 0, do this assignment to var out, then break. Otherwise, if it's 1, do this assignment to var out, break. If it's 2, make this assignment. If it's 3, make this assignment. If it's none of these, do this. So a switch statement can look like this in a flowchart. You have a process that says check var in, and then you have these decisions that say, is var in case 0? Or is it case 1? Or is it case 2? Or is it case 3? And you kind of have this thing where you go through and it's like, if it's yes, make that assignment, and then you're done. If it's not, go down and check whether it's 1. If it is, go over here, make that assignment, and you're done. If it's not 1, go to 2. Either if yes, make the assignment and you're done, or no, go to case 3. Same thing, make this assignment, and then you're done. Or this would be the default case. And this really is how you code this up, because you really do test it or compare it to see what it is, and then you make a conditional jump to a set of statements that implement what you're trying to do for that particular case. And then this line right over here is kind of the functionality for the brick. Okay, so that's the basics of it, and it's always a good idea to sketch out flowcharts whenever you start designing a program. And when you get used to it, it'll actually make the coding go a lot faster. All right, remember, subscribe to my channel so you can stay up to date on all the latest videos. Goodbye.